go
intro?
on
You're
mute,
going to
okay.
intro me or no?
Um,
My name is Jason Lang. I'm a senior solutions engineer with F5 Shape Security. Thank you for attending this morning. Today I'm going to go over how you can use F5 technology with F5 Shape at the forefront to help defend your web and mobile applications from unwanted fraud and abuse. We have a very exciting presentation for you today. I hope you feel the same at the end. So I'm just going to jump right in here. A little bit of levity, I suppose, to open things up on a Tuesday morning. I would, if we were in person, I'd say, hey, how many of you in the room put up your hand were able to snag a PS5 or an Xbox Series X at Christmas? I certainly wasn't able to. Don't think many others were either. And the problem with that really is because of bots, bots on retail, bots on shopping sites. Of note, a lot of those sites don't have Shape in place, and that's why we're in the situation we're in, unfortunately. Now, maybe you thought, oh, I'm not really a console person. I really would rather just build out a sweet gaming rig and put some of the newest graphics cards in there. I have some bad news again. Unfortunately, bots took those too. And even publicly on some well-known forums and technology news sites, they'll even help you build a bot out of a Raspberry Pi computer to help overcome the protections that are in place on these particular retail sites, which is really unfortunate. But maybe you're not really a technology-minded individual. Maybe you prefer something a little low-key, especially after we've been in various forms of lockdown here in Canada. And maybe you wanted to go camping, but because of the restrictions, you have to book your campsite online. Sorry. Unfortunately, the bots got them too, and they're selling them at a pretty steep markup. You might be surprised to know that a lot of these sites are protected by a leading bot vendor offered from their CDN, and clearly not particularly effective against the type of traffic that they're seeing. And why is this still happening? It's 2021. I thought we were supposed to be in the new era, the new age. And the problem really stems from the fact that this is a prolific issue, certainly. With the wrong tools in place, it's certainly not easy to provide this level of protection. And the problem is exacerbated by the fact that security, DevOps, ITSecOps, etc., is generally very siloed and separate from the risk and fraud organization. And those two, between security and risk, often are at odds with marketing or the digital transformation leaders within an organization. And there's a lot of silos still within organizations, and that leads to a variety of different issues, namely that different technology platforms with different features and functions don't generally work well together, and there's not a lot of communication between groups because those systems are very siloed as well. And so what we're here to show you today is really to help you make your job easier, really to help you become the superhero that you are and shine a little brighter by bridging the gaps between security, fraud, and marketing with a single platform that is powered by data, your own data, to help you inform the decisions that you're going to be making. And so here at F5 Shape, we really like to think of the solutions that we're going to show to you today as a digital transformation enablement tool, both on web and on mobile. Now, I want to make it clear that when we're talking about this, we're really talking about the business to consumer space, where you are offering something to your customer base, where a customer would be any random person like you or I visiting your website or using your mobile app to procure some type of services. And it really doesn't seem to matter whether you're in retail, financial, hospitality, travel, etc. If you have a login function on your website or some type of gift card on offer or something where a user is submitting data to get access to something in return, you're very likely a victim of abuse and automation. And so with this platform, we're really able to shine the light on three specific areas. The first area, and this is where Shape got started initially, is are you a bot or are you human? And we can solve that solution very effectively, as we will show you, with one of two products. And that really appeals in many cases to the security group within the organization. If we pivot from bots and instead now focus on the leftover traffic, which is the humans, we have some products that really appeal to the fraud and risk management teams in identifying likely suspicious human transactions, the fraudster activity, in a unique and novel way that is showing extremely promising results compared to other solutions that have been on the market for decades. And finally, if we have time, I know it's not the focus of this presentation today, but can we help accelerate the digital experience of the known good user? Can we give them the Amazon experience where every time you visit Amazon on your laptop even, it knows that it's you and it's sort of automatically, persistently always logged in? Can we extend that type of experience to anyone in the industry? And the answer is, of course, we can. So you may not have heard about Shape. So Shape was acquired by F5 in January of last year. We protect over 40% of the Fortune 500 business to consumer brands. Some logos here on the screen might be somewhat familiar, even some brands here in Canada. But we are there protecting the most targeted organizations from fraud and abuse. Now, certainly don't get the perception that, well, I'm not in the Fortune 500, so I'm likely not appropriate for this type of protection. That's absolutely not the case. Part of the value that F5 brings is ease of integration and a number of simple integration points through Silverline Cloud Managed Services, for example. And where we really got started was with the likes of Starbucks, Chase, and JetBlue in solving a problem known as credential stuffing. This is the number one, well, was the number one security threat in 2020, not too long ago. Credential stuffing is when I take breach information from other breaches not affiliated with you at all. And in many instances, those breaches contain credentials, email addresses, and passwords. And as humans, we are often very lazy and we might reuse passwords, sometime intentionally. I do it myself on sites where I don't have any PII or anything sensitive stored. But even most internet users are going to reuse their password because a lot of the problems are the password requirements today are so crazily complex that I'm just going to pick one password that meets all of the criteria and I'm just going to use it everywhere. And bad actors take that to their advantage. And so there's billions of credentials, usernames and passwords, often in the form of email addresses and passwords. And they simply take those lists and they target a random site where they think that there's some value to be had by getting into the login and behind what's behind the login. And this is a term that Shape actually coined called credential stuffing, where we're taking credentials and just stuffing them en masse at a login portal, for example. In a retail scenario, you might see something similar, more commonly referred to as brute force, where let's say you have a gift card, and so you can go into any Rexall or Home Depot or Shoppers Drug Mart here in Canada, just flip the gift card over, and often you can see the numbers that the gift card starts with, and then you just take a picture of that with your phone and then just get some automation tools to just iterate one after another, every possible value and every possible CVV code en masse. And ultimately, you will end up with some gift cards that have funds in them that you can use yourself. So this is a rampant problem to the point where 90% or more of traffic to a login page is automated. And we see this across the board at many, many different targets, regardless of the vertical. Now, this is certainly not meant as a dig here against F5 and its great WAF-based product, but it is simply there to mention that WAF-based protections generally are not able to correctly identify and address the scale and the scope of the automation problem. This is a screenshot from a competing cloud-based WAF tool of an actual customer's traffic, the same customer's traffic actually we're going to see in the next slide. And according to this particular WAF, they assess the bot problem at approximately 1 to 3% of their traffic. And you can see here in this sort of bluish cyan color, there's barely any bot traffic identified. And yet, look at these spikes of traffic here. Is that human traffic? We don't know, except Shape does. So this is that same customer's traffic, different time period. However, this is the first 30 days of Shape being deployed on the login page. We see here 89% of the traffic is not the human traffic. The traffic in yellow is the traffic that's been highlighted by our solution as automation, not coming from a human. And in red is when we go into mitigation mode. So this particular customer had both a web and a mobile application. And we went into mitigation mode first on the web. And that's what we can see depicted where the first little bit of red here kicks in. Not 2 days later did the attackers pivot to the mobile application. So what happens oftenly, as you know, in security, if you close the door, if you don't close all the other doors and windows in the building, they're just going to come in through another angle. And that's indeed what we see. Attackers pivot within days, sometimes hours, to another method of access. So in this example, they pivoted from web to mobile application traffic. And this is really what we're able to call out. Interestingly of note, this shaded green area here, this is the actual human traffic. And so there can be immense savings when you can get this level of visibility, because if we can knock down all this automated traffic, we will see that the automation is sometimes 10 times, 20 times higher than the human traffic. If you're paying for public cloud-based infrastructure, that means you can drop the bill. So business benefits in terms of reduction of costs simply by flagging and removing all the automation that's present. And another point to mention as well is there's a lot of different bot solutions on the market, certainly. A lot of them leverage lists of known bad, botnet lists, IP reputation lists, signatures of known bots. Those are not particularly effective anymore. They haven't been for a number of years. I would like to say that even the most simplistic of threat actor to load up an open source tool such as OpenBullet can often bypass these. And they're able to do that because of the prolific distribution of VPN services that are available free of charge in many cases, often with VPN exit nodes within the country. So you might be tempted to say, well, I don't deal with anyone outside of Canada, so I'm just going to block everything outside of Canada. Well, that'll only work for a few hours until the bad actors pivot to proxies within Canada. There are over 4 million proxy IPs in Canada. So geo-based blocking is simply not an effective tool, and IP-based blocking is not an effective tool either. As we see in this same customer's traffic with an expanded time range here, 4.3 million different IP addresses were used as the part of the attackers. That would likely exhaust any IP-based reputation list and wouldn't be very effective for very long. And interestingly, apparently 5.8 million different user agents. A user agent is a string that a browser used to identify itself. Generally, the browser version, the operating system version is purported. Within web traffic, you can just make up any user agent you want. Unless your bot solution or your WAF solution is challenging that particular device to make sure it's authentic, any signature-based blocking will simply fail to account for all of the possible random variations that, again, a low sophisticated attacker could use. The other thing is that there may not just be one attacker. You might be targeted through multiple different threat actors using different infrastructure, and you really need a solution that's effective that can identify this easily and block it. And so we have such a solution, of course, two different variations of effectively the same engine or the same technology. We have an integration with F5 Silverline Cloud Services Portal called Silverline Shape Defense. Or we have a more bespoke custom white glove service that is used by, again, a large proportion of the Fortune 500 that we call Shape Enterprise Defense. Both of them effectively work the exact same way, They deploy JavaScript or mobile SDK onto your application. On the web, there's generally no changes required by your application dev team. This can all be done dynamically through F5 Big IP. And we can simply then run interference on the site, portions of your site that might be subject to abuse. So pictured here is the login for a bank, for example. And so Shape is very easily, almost trivially able to identify automation and then take action and block it before it ever reaches origin. And we do this in a way that's transparent to the bad actor. So we're not simply issuing a 404 or some type of message that indicates that we've blocked them. We will serve the exact same page and the exact same error message that you serve today. So we're a proxy that is acting on your behalf and blocking the unwanted automation. Now, most all bot solutions today leverage JavaScript, but no other vendor other than F5 Shape has contributed more to the actual JavaScript standard in terms of new features than Shape. In the standard introduced in JavaScript in 2019, 5 of the 9 new features came from Shape. And they came from us because we're pushing the boundaries of what JavaScript can do client side in order to fight automation and abuse. So what our solution effectively does, and this is true both on web and in our mobile SDK, is we put information into 3 buckets, and we're trying to gather telemetry about the device or the environment, some high-level network information that any vendor would have access to, but also the human behavior data. So from the environment perspective, we're going to see if it's running a virtual machine, some other type of aspects about that environment in the browser, what type of plugins they're using, which browser version they claim to be, whether they are or not that browser version we're going to get into next. On the network level, we're collecting all of the HTTP headers, and in particular, we're paying attention to the header order. A lot of bot infrastructure tries to mimic a real browser, but doesn't successfully do that in many cases. So in some instances, we can easily pull that out simply by looking at network telemetry headers. Not very often though, but it is still interesting information that we can gather to provide some additional intelligence behind the scenes. But one of the larger buckets, and this is especially true when it comes to the fraud space, where we're not really talking about automation, but we're trying to identify bad human actors, is how is the user interacting with the page? Are they typing at a regular speed a human would type at? Are there natural variations in the key up, key down timings? Is the mouse moving in an organic function, or is it just jumping exactly to the point where it needs to be clicked, or the exact same coordinates every time? Are they using strange keys? Are they alt tabbing in and out of the browser? Are they using copy paste? Are they pasting values and then backspacing the last 4 values in between every single transaction? So it's that level of information that we can pull out to make our bot or not decision. And we don't just need to see one thing going sideways. We need to see several things that look suspicious in order for us to render a real-time decision. Now, again, as I mentioned, most bot solutions work very, very similarly. The number one competitor, which is a CDN-based bot solution, you can read their JavaScript in the clear and see exactly what they're collecting and therefore what to spoof in order to bypass it. It's quite easy to do. There's some public available, we've issued a number of patent requests and those have been granted. And this is one of those examples where we have anti-spoofing detection at play. So again, as I mentioned, a user agent string is just a string that you can send to a server to identify the browser version, operating system, and operating system version. You can make this string anything you want. So in many bot tools, they randomize the user agent string to try and get around signature-based protections. So as an example, let's say that in my user agent string, I claim to be Firefox on Windows 8. Well, you might not realize why all the browser vendor versions and all the mobile versions like Apple and Samsung put out new emojis every time they release a software update. The reason for that is for things like browser profiling. So if the user agent claims it's Firefox version whatever 82 on Windows 8, we will issue a transparent challenge in a hidden iframe on the web to say, go render the smiley face emoji. And we will then look at certain color characteristics of certain pixels and can deterministically in real time know whether that device is authentic or not. So this is something that I think only Shape has been doing for a number of years now in proving whether or not that environment is lying. A good human would never lie. Automation lies all the time. They try and automate the randomization of so many variables in order to bypass other competing solutions that we're able to uniquely pick these things up and catch them. And so this is an interesting article that's a real world application of that. This article came out a couple days ago talking about a bot farm inside of Facebook that was leveraged for political influence in the US election. And they went to talk about how many different accounts that they found through this open infrastructure that was just unsecured on the internet, that they found all of these different tools. And what they discovered is that they're using something called Selenium. Selenium is not a bad tool on its own. It is used in many cases by commercial quality assurance automated testing toolkits. What it does is it drives a real browser. So inside Selenium, you can configure the tool to record human transaction data, for example. So in a QA function, I want to make sure that I can do regression testing of my entire website. So I might use something like Selenium to do this. And what they found is that Selenium was being used to register thousands of accounts, issue thousands and thousands of posts, cross-liking those posts between each other, and of course then exposing that to the real world and the people that were falling victim to these particular political persuasions. And the key here is that F5 Shape is actually able to detect the use of Selenium and these types of cool toolkits that record and replay human interaction, or even just mimic the human interaction by inserting random delays into the human interaction data points. And so, this particular research article sort of hinted that, well, there's nothing that can detect this, and that's not true. Shape can absolutely detect this level of automation. So at the end of the day, with Shape deployed, this is what almost every customer we have looks like. Less than 1% automation. Contrast that to what I showed before. 89% automation, and this is very common. 89% automation, 60% automation. The highest I've ever seen here in Canada is 99.97% automation, which was the login traffic for a quick service food restaurant chain. This is our outcome. We are a managed service. We provide the best possible protection against automation from any other vendor on the market. And this is our promise to all of our customers that less than 1% of unwanted automation reaches origin. Now, what is this costing your business? If you are a target, this is not simply the cost of the traffic or the extra infrastructure provisioning costs if you had to horizontally scale your cloud within AWS or GCP, for example. There are real costs to automation. If the particular attack vector is credential stuffing, so again, testing of lots of credentials against your login, our data states that over 1 to 3% of any sufficiently large list of credentials will result in success. So if I have 1 million usernames and passwords and I target a particular organization, 3% of those, right, or 30,000 accounts will be harvested correctly because of username and password reuse is one example. And a side effect of that is many of those accounts that weren't successfully compromised might get locked out. Therefore, that particular actual real account owner has no choice but to call the help desk to get their account unlocked, which costs you money. It's costing you infrastructure hosting costs. It's costing you your own team's time and effort trying to fight this problem with the tools that you might have available, let alone the direct reimbursement if any fraud were to happen as a result of an account takeover. So as an example, Starbucks is a large customer of ours. Per capita, every person on the planet has $20 worth of Starbucks credit. So if I was to take over someone's account, there's likely to be 20 or more dollars in there that I could use to my own benefit. So the costs from a fraud perspective are generally 2 to 5 times more than the actual dollar value loss. So for a $20 account, could it cost north of $100 for you to remediate that single account? And you could have thousands of accounts compromised per week, as that other customer did that I showed earlier. So the cost can certainly balloon. Now, there's some things that you can do that don't cost anything to try and shore up your own defenses. And again, we're not talking about any type of vulnerability or security threat. We're simply talking about bad actors using tools to take advantage of how your website works in terms of trying to figure out if there's user accounts, for example, that have been um, poorly secured. So some things that you could do is just delete old accounts, remove the threat surface. If a customer hasn't dealt with you in a number of years, consider communication obviously to them and just removing the account entirely from your system. One thing that sounds counterintuitive, but we're certainly seeing a greater and greater focus here, relax your password requirements. Don't require alphanumeric passwords with a special character and a certain number of capital letters. Simply require a longer password. 12 characters or more is preferred. Let them pick anything they want. Multiple real words from the dictionary strung together randomly is far more secure and will take much longer to crack than any alphanumeric combination of 8 to 10 characters. So again, give users freedom to select long passwords. Reduce feedback on any login or account recovery page. What we definitely don't advise is if the username or password is wrong, don't give the bad actor any feedback as to why something might not be the case. Don't say, hey, that username already exists, but the password isn't valid. Or, sorry, I can't find that username in our system. Because that indicates that, oh, well, that user doesn't exist. So I'm going to go target the usernames that do exist within your platform. So simply respond to things like login failed. Don't state why, just make it as generic as possible. Something that you can definitely also do, which I highly recommend, and very few are doing this, is put your web and mobile traffic into some type of graphical dashboard. There's lots of open source and free tools available. Look for day-night patterns. If you just see scary spikes all the time, that's a good indication that you have some automation. And finally, at the account level, monitor some key metrics. Look for how many user login events were successful versus failed. You should see at least 70% of your logins successful all the time. If you are significantly below that number, or there's a period of scary looking traffic, which looks like a rectangle or very spiky, and the login success is 1-2%, that's definitely an indicator that you've likely been subject to a credential stuffing attack. Now, if we take the bot scenario and we place that to the side, the logical next step for bot attacks is to conduct some type of fraud. And we have a solution for that as well that is going to focus on the humans. But let's just paint a picture here. In many high-profile targets here in Canada, especially in financial sector, but certainly not limited to that. It could certainly be telco, anything where, again, there's perceived value behind the login form in a business-to-consumer type relationship. Fraudsters may target victims with phishing attacks. You can buy on the dark web an exact replica of the CRA's website with the click to log in through an authorized partner, so through a bank. You can buy these phishing kits for about $50, deploy them on a compromised server, and try and trick victims to submitting their credentials and all of their PII to these sites. You would think that a lot of people in this day and age wouldn't submit their information, but the reality is over 80% of Interac email money transfer debit fraud is because of phishing. So this is very profitable for the bad actor. So if you've ever received an email, more likely a text message purporting to give some sort of refund, either your credentials are expired on Netflix or Disney Plus, even if you're not a customer of those services. Certainly don't click the link, but just know that hundreds of people a day do fall victim to that, and to just be on your guard. Now, in many cases, these sites look identical because they're actually pulling the content from the origin site. So they're pulling that particular bank's site traffic in real time and presenting that to the user. So they're none the wiser. They think they're logging into the actual bank site and they give their credentials over. And so generally what happens with this, whether the credentials were harvested through an automation credential stuffing attack, or they were phished, bad guys have return on investment too. They have to hit, but they have a certain profit margin, so they can't spend all their money trying to attack. They're then going to scale their organization out, and generally that means hiring a few individuals. Maybe you've seen posters on light posts offering $1,000 a week work from home job. You don't really have to do anything. This might be one of those things you're doing. You might be unwittingly using harvested credentials to log into real victims' bank accounts in order to transfer money. And we see this again and again. Here, certainly in Canada, in the financial services space, in the credit unions and even the big five banks, we see this very, very commonly done. But it's not limited just to banking and financial. If there's anything within your site that could be particularly monetized, even just excessive amounts of personally identifiable information. So if you're in insurance, for example, if I can log into a victim's profile through your login portal, and I can collect all kinds of information, their date of birth, their social insurance number, etc., that's certainly of value. And we see full packages of people's identity being sold on the dark web. So from a fraud perspective, the challenge has always been over the many years of different solutions being cobbled together to try and prevent fraud. And in many scenarios, just because this is the way that the security world works, a lot of things are predicated on rules. The sad reality is that the fraudsters simply test the extents of all of the rules that may have been devised. And again, they're taking advantage of that siloed approach. The security team, through their WAF and their other security controls, might have a number of rules defined, but it doesn't talk to the fraud or risk engine, which has a different set of rules applied, and then the identity and access management portals, whether they're third party or developed in-house, also have different rules applied, none of which really talk to each other. And the bad actors simply test the extents of those particular rules and then walk straight through. Now, there's been a lot of noise lately that, oh, well, I'll just put multi-factor authentication on all of my users, and that's going to solve the problem. Well, maybe, but from what we've found, not particularly. What we're seeing more and more is the bad actors are now being driven to target where that MFA lives. And in many cases, that's the telco. So as a bad actor, if I know that my particular victim deals with a particular bank, and that bank uses SMS-based verification, when I go to log in, I get a text message and I need to answer this 6-digit code that's sent to me. Well, that's a signal to the bad actor that they then need to somehow take that number over. They need to port the number over to their device or do a SIM swap. And so what we see is they will attack the telecommunications provider with credential stuffing, for example, and try and get in to harvest the information. They'll download a few months worth of bills to get all the information they need, and then they might port the number to basically transfer the number away from the telco that the victim deals with into a VoIP provider, for example. And this can be done, again, automatically, and therefore the bad actor can then conduct their fraud scheme generally in the middle of the night when they move the number over, or they do a SIM swap when the victim is sleeping. They empty the bank account because the two-way SMS code goes to the victim now. It goes to the fraudster, not the victim. And at the end, they make off, and it's really hard then for the victim to claim their fraud case because the bank will say, but you answered the security challenge, so now you're trying to defraud us by saying that your bank was emptied and yet the SMS verification was answered successfully. So this is just something to be aware of that is happening. The other thing that's happening, and this is a really scary trend in my opinion, is this attack now going directly after the email-based providers. And the driver here, as far as I've been able to see, is really around the passwordless authentication that's been taking off recently. Rather than having users go through the friction of having to enter a password, apparently now they'll just send you an email with a unique link. Sounds good. As a customer, I don't think it's any less friction than having to put my password in. And from a threat vector perspective, it's probably worse because what we're seeing more and more is the bad actors are now targeting your email account. If they can get into your email account, then they can obviously very easily see everywhere that you conduct business where you use that account because you've registered for accounts elsewhere at your bank, at a variety of retail stores, hotel, hospitality, travel, and then they simply reset the password. So they go to that particular target site, and because they control the email account, they simply go through the forgot password flow and they input the email address, and then the system sends a link to the email account, which is controlled by the bad actor, and they simply reset the password. And they may even go so far as to set up an auto forwarding rule in the email account so that the victim doesn't know that this is happening because the emails will then go to the bad actor. And so if you're using frictionless or passwordless MFA where the challenge goes to the email, I don't think this is a particularly wise idea. And we have a solution, of course, that we can show, but I just wanted to highlight that this particular statistic, this is monitoring of a dark web forum, just one of them. There's many, many forums on the dark web. This is a graph of the number of email accounts being sold. So email access only has grown over 600% in over a year. And what we find here at the bottom, for example, this is a one forum where they're selling accounts to samsclub.com. I kept it south of the border, so it wasn't alarming here in Canada. And the note here is that it's mail access only. So what you're buying is you're buying access to this victim's at Time Warner company, twc.com. You're buying access to their email account. And from within their email account, then you can reset the password to get access to their Sam's Club account. And this is a very, very increasingly way that we're seeing more and more of email addresses being compromised, leading to account takeover through account recovery flows, so password reset. And so is the MFA on everybody a solution? Not really. Bad actors are now targeting the MFA infrastructure. And more alarmingly, even these third-party auth providers are triggering a lot of MFAs. In one particular example, 5 to 10% of a customer's logins might be MFA'd because their system just doesn't know. But with Shape in place and our fraud engine, we can reduce the number of MFAs drastically by 99%. And only trigger MFA for the flows that really need it. And so what this really means is rules-based systems aren't particularly good at detecting fraud. Machine learning and AI, of course, everyone says they have it, but when it's applied correctly through using human interaction data, and this is the key, we're not looking at things like IP address, and geolocation and more primitive location-based indicators. We're looking at the human data. What is the human doing when they're on your login page? Are they doing suspicious behaviors? In retail, are they submitting lots of orders where the zip code or the postal code here in Canada is changing, meaning that it's probably a fraudster submitting hundreds or thousands of orders, likely using stolen credit cards? These are the types of things that our fraud engine are able to pull out in a machine learning model with extremely low false positives. And this can look like the following, where let's say that you have a website and you have rolled out a knowledge-based 2FA after the login. And so in this particular instance, we've seen, for example, a single device, single browser attempt to log into over 72 different accounts and successfully log in to 43 of them. And they did this by copying and pasting the username, the password, and the knowledge-based second factor authentication in order to access the account summary page. This is irrefutable proof that Shape is able to provide on what the human is doing in terms of a fraud angle or fraud vector. If we look at that particular device, we can also look to see over how much time different accounts were attempted. And this is very interesting because, again, this is not normal human behavior. As a normal customer of a bank, I'm only logging into my account. I'm not using my laptop to log into hundreds or thousands of accounts. It's certainly not like a library or an open kiosk because, again, we see things like copy paste be used on the login. So this is a very rudimentary visualization of a login event, but we can see in this particular scenario that they're pasting information into the user ID and the password, and then they're clicking the login button. And that's what we see over and over again. We're looking at the human behavior. Now there's a question here in the Q&A panel. Can we tell the difference between a password vault or password manager and pasting? Yes. Password managers generally use the autofill API built into browsers. So it is not a copy paste event. But as I mentioned before, just because you're copying and pasting doesn't necessarily mean we're going to do something untoward. We need to see a whole bunch of suspicious actions happening at the login. So in this example, there's copying and pasting. We also see, based on these little green ticks, that's hard to picture perhaps, but they're going off the screen and they're likely copying and pasting from some sort of notepad or an email the credentials. And again, we're seeing tens of accounts attempted in a very short period of time from the same device or the same browser. And so what we can do is we can deploy our solution across your entire website, build out a journey of what users do compared to what fraudsters do. And in real time, you can trigger a fraud score and a decision. This decision in most cases, in 99.8% of the time, it's going to be allow. For those where we have a heightened sense of something's a little suspicious, we've seen 2 or 3 accounts attempted manually. They weren't successful. We might issue a next time we want you to challenge that particular interaction through calling a third-party identity and access management platform like an Okta, for example, or an Oracle Access Manager. We might say, something's really odd. We should review this with a fraud team or block. And this is truly in real time. So the page will react and the threat score will change dynamically through the same interaction. And for every single user navigation event where they're clicking something or submitting something, we are dynamically changing and calculating the score behind the scenes and can provide you a risk indicator. Again, challenge, review, or block. And then it's up to the enterprise for how they want to enact that particular policy change in their backend. And so just to close out here, this is the second last slide, is, what does this get me? So this is, again, machine learning derived fraud detection above and beyond a rules-based instance. We're able to detect 2 to 3 times more fraud with our AI ML system than commercial fraud tools. So this is a Canadian financial institution through 2 fraud commercial tools and a commercial fraud rules-based engine. On average, they're detecting about $300,000 worth of online fraud on their web per month. With the application of our user behavior signals tuned to detect fraudulent behavior, we're able to increase their detection. So above and beyond what they're detecting today, 177% more fraud with a 0.1% false positive rate. This is fantastic. This is getting them to about 61% of all of their fraud being detected in real time with Shape, compared to about 19% of their total fraud being detected in-house without Shape present. And so we're able to deliver on the fraud space much better outcomes in terms of percentage of fraud detected, or what's known as recall, with very low false positives rate. If you're using it to trigger MFA, we're going to generally be triggering 90 to 98% fewer MFA challenges, because we clearly have some intelligence there that's a little bit more sophisticated than simplistic device ID based information. And again, we're a managed service on the fraud side, so we're able to take advantage of our expertise, so it's not burning cycles of your own staff trying to fight these problems. So in closing, hopefully you found this somewhat interesting. We have a lot to share. At the end of the day, what I really like to summarize is that Shape is really a data science platform. We are certainly providing much value through simply just getting us on the page to provide you some insights that maybe you haven't seen before, both from a fraud perspective as well as an automation perspective. And then what I hinted as well, but didn't really show today because we ran out of time, is how can we help accelerate the digital transformation space? Can we indicate if there's areas of your site that are experiencing some user friction, and can we help remove those friction points to make it easier for your users to conduct business with you? So if you want to think of that, think of transparent authentication, silent re-authentication, or invisible MFA. So with that, I would recommend, if there's any information you would like to get or more information, certainly please stop by the F5 booth that's going to be running over the next 2 days. And it's been my pleasure. Again, my name is Jason Lang with F5 Shape. And at this time, I'll take some questions if there are any.
Hey, Jason, I put a quick question in a chat. Is due to growth of number of virtual VDI environment in some modern OS, how we would solve that problem and make sure that his legitimate user is not getting blocked?
Yeah, excellent question. So we're certainly seeing a lot more of growth of the VDI infrastructure. Would have to be, again, it's not just one signal that we're detecting. So yes, okay, you're in a virtual environment, that's fine. We need to see a multitude of suspicious signals occurring at login, for example, if it's a human. Just because you're in a virtual machine is just one of hundreds of factors that we evaluate in real time. So we would very likely not generate a false positive with that. We are definitely I want to issue some caution. A lot of solutions will certainly benefit from being able to drop cookies, first-party cookies in VDI infrastructure. I think that would be a wise decision to allow that VDI infrastructure to persist cookies across sessions, because a lot of systems would rely on those cookies being present in order to reduce friction events where that device appears to be net new every single time it's launched. And so that certainly, just take that to heart to try and make sure that if any particular security control or system is putting cookies on that particular virtual environment, that those cookies persist over the session, which I realize is pretty hard, because in many cases that virtual machine is being spun up from scratch every time you launch the instance. But we've certainly seen some issues there.
That's good, Jason. Thank you. Looks like we have 2 minutes. Any other questions? If not, please stop by our booth. There's always someone. I'm your F5 account manager. There's some other individuals. We can have one-on-one discussion how this could be applicable to your specific environment, wherever it's public sector, healthcare, government, financial, retail, any of those. I'm probably missing some as well. Well, I think you did an excellent job of explaining it, because it doesn't look like there's any more questions. Thank you, Jason.
Thanks, guys.
Thanks everyone for joining. Enjoy the rest of your sessions.